Hello, thank you all for joining us today. We appreciate you being here. If you could, go ahead and send me a quick message in the chat box and let me know if you can hear me okay. Quick audio test for us. Wonderful. Here I'm coming in clear. I appreciate too if you bear with us today with everybody working from home. I know the audio quality can be hit or miss. I know our GoToWebinar systems, as many systems are, slightly bogged down by the extra workload of everyone working from home these days. So bear with us on that audio quality. We have been doing some tests for the last half hour here. It's been pretty clear, at least understandable. So I ask you to bear with us today as we have some different circumstances that we usually do for today's webinar. But nonetheless, hello, welcome to the Digital Enterprise Society webinar series. And today's webinar, Embrace Digital Transformation and Leverage Big Smart Data. I will be your host for today. My name is Courtney McWhirter. Digital Enterprise Society is a new nonprofit member association organized to enable the transformation of product development, design, delivery, and maintenance throughout the digital enterprise, regardless of software tools used. We are dedicated to the transformation of the manufacturing enterprise workforce. I invite you all to join Digital Enterprise Society if you're not already a member. You can find the link there at the bottom of the screen. Again, my name is Courtney McWhirter. I'm the Marketing Communications Manager for Digital Enterprise Society. If you have any questions about joining or getting involved with us, we'd love to have you. Please feel free to contact me with any of those questions. Before we get started, I also want to encourage you to type any questions that you have today throughout the presentation in the questions field, and we'll have a brief Q&A following the presentation. Today's presenters are Mo Abuali and James Ricci of IoTco. I'm going to let them go ahead and introduce themselves. So I'm going to turn it over to, I believe Mo is going to introduce himself first, and I'm going to pass the slides over to James now.
Yeah, Courtney, thank you very much for the opportunity to participate in this webinar, and appreciate the partnership with Digital Enterprise Society today. This is Mo Abuali. I'm a managing partner at IoT company, IoTco. We provide 3 lines of services to manufacturing companies, focusing around digital transformation, industrial IoT, and predictive analytics. Today will be an education together with my colleague James. My quick background is I have about 20 years in industrial engineering, having worked half of my career in manufacturing, companies like Toyota, and the other half of my career I worked in the software space around industrial IoT and predictive analytics. So I appreciate James being here, and I'd like James to introduce himself and to take it away. James?
Thanks, Mo. So, good afternoon, everyone. I'm really excited to speak with everyone today, but before I really dive in, I'd like to also provide a little bit of background on myself. Not so much as a commercial, but more so for context to the kind of the information I'll be sharing. So my whole 30-year career has really been built around manufacturing. Whether early on as an engineer at Honda, working on quality and production issues, to eventually actually running operations for other companies. Now, for the past 10 years, I've really been focused on improving the competitiveness of middle market manufacturers. And increasingly, my time has been spent leveraging technology to kind of operate smarter and drive profitability and throughput. So this webinar that Mo and I are doing today was originally intended to be a primer for our event at Foreseeable headquarters in May, but that event's going to kind of have to get rescheduled. But our presentations at the event, we're going to go into a lot of detail and contain a lot of examples and case studies, but we're still going to cover a lot of that today. And Mo's actually really going to do a good job covering some case studies today. And he's also going to do a deeper dive into the industrial Internet of Things and what it means to be really a connected factory. And then we're going to wrap up the webinar with some lessons learned, followed by any Q&A that anybody on the line may have. Now, what I'd like to focus on are kind of the issues impacting widespread adoption and of Industry 4.0 and some ways to overcome them. So really my first lesson learned, if you will, is for everyone to try to avoid using the term implementation. That's why you're going to see it in quotes throughout my presentation. And I prefer to use the term transition because, implementation really implies more of an event with a defined completion, like, hey, we've completed implementing Industry 4.0, which really doesn't really make a lot of sense. But I do want to first briefly level set everybody on my definition of Industry 4.0 kind of before proceeding. And I'm not going to get into what Industry 4.0 is in relation to Industry 1.0 or 2.0 or 3.0, though Mo does have a slide on that a little later. I just want to take a second to at least commonly define it so, we're all on the same page. And there's a couple things that I think are important to call out. One is it's using machine-to-machine and industrial internet deployments to increase automation. That's kind of the obvious piece, right? So we're taking traditional manufacturing practices, albeit good operating practices, and we're marrying them with technology. And a lot of times this plays out as most obviously through automation. But I want to call out a couple other things here, like the words communication, monitoring, diagnoses. Diagnoses is a big thing. Mo's going to talk about that later, and really new levels of analytics. It is also about smart equipment though, but it's just not smart equipment for the sake of having smart equipment. But again, it goes back to analyzing and communicating so that this smart equipment talks with each other, but it's also talking with people. Okay? So I'm contending that this quote unquote implementation is accelerating, but it's not fast enough. And there's a lot of factors, both micro and macro, that are really driving this. And you can see a lot of these have come up on the screen, and you can see things such as adapting to product volume and service mix changes. A big one these days that's driving the acceleration is this talent and skilled trades availability. And honestly, a big one is down at the bottom. It's a lot of software and hardware advances and everything that I've got listed there. And the cost for these is dropping dramatically. So again, if you think about something like machine learning, right now, Azure ML through Microsoft, they provide their entire machine learning capabilities effectively for free. So that's a tool that you can use. But when you look at things like pricing, quality, delivery, all of those pressures, this is a tool that helps address that and mitigates a lot of risks that we face today. So this implementation needs to accelerate. It's helping us find new ways to, what I'm going to say, win. In a lot of cases, it's also finding ways to generate new revenue streams in the business. And we can even cover some of those examples if you've got questions on that, but we'll definitely be covering that in our larger event at Foreseeable. So we've got these tools at our disposal, but the biggest takeaway is around this risk mitigation and, quite frankly, linking back to your business plan. So again, we want to do these things, but we don't want to do any of this stuff in absence of a business plan. So I'm going to talk quite a bit about that. That's a big issue that people tend to miss. But what I'm not blind to is some of the real challenges to making this happen. And this is going to actually be a poll question here, these challenges that you see up on the screen. You know, a lot of these challenges that you see right now are really self-inflicted for sure. You know, whether it's a lacking of an MES system or a poorly deployed ERP system, you know, having outdated equipment, outdated software, outdated drivers, quite frankly, just not having skills in-house to execute what needs to get done associated with this transition to Industry 4.0. It's figuring out, establishing processes and kind of making them stick in the business. And it can also be, quite frankly, as simple as you just don't have the money. So with that, I'm curious, Courtney, if you could open up the poll question and we can kind of see what everybody thinks could be their situation today.
There you go, James. We've launched the poll for you all. If you could jump in and respond to that poll question you now see on your screen. What is the biggest tactical challenge to accelerating your Industry 4.0 transition? So far, a lot of people have said skills needed are not in my organization. We also have money to invest in all of this. Our two biggest answers right now. Issues with MES and ERP system is up on the board now. Lots of folks choosing outdated controls and software, skills needed. We'll give you just a few more minutes, or a few more seconds rather. It looks like about 68% of you have jumped in and answered the question. So if you haven't yet, go ahead. All right, so currently, James, we have about 31% say the issue with our MES and or ERP. 41% say outdated controls and software or dated dumb equipment. 29% have come in with the skills needed or not in my organization. 41% getting processes built on the new technology. And then finally, 47% saying the money to invest in all of it just isn't there. So I'm going to go ahead and close that poll for us and give the slides back to Jim.
Thanks. So again, it sounds like a lot of people have similar sets of issues, whether it's the money or the ERP systems or the equipment. So we're going to try to address some of that with some of the best practices and lessons learned. So again, this doesn't have to, the short answer is this doesn't have to be super expensive. So to kind of take away that issue now, getting through a poorly implemented ERP system takes a little bit more of a challenge, but we're going to try to cover some of that as well. And as I talk through these challenges, these things impact both small and large companies really in very different ways, all of these different challenges. But, when you think about small companies, set aside that for the most part, small companies are mostly privately held and family run versus maybe these larger publicly traded companies like a General Motors, for example. But one thing we want to make clear, have everybody to understand, is really small manufacturing is the backbone of the United States from a manufacturing perspective. And kind of further to my point, the Center for Automotive Research just published an article related to COVID-19, and in it they stated that roughly 75% of all auto supplier establishments employ fewer than 100 people. And according to this data from the U.S. Census, 94% of all manufacturing companies employ fewer than 100, and in fact, 99% are below 500. And to give you some sense of scale, a 100-person company is about $25 million in revenue, and that sort of 400 to 500-ish size company of employees is going to be in that $125 million range, okay? And not only are these the vast majority of the companies, they in fact create the majority of the value. So in this case, these same sets of companies that are highlighted and bolded in this red, they account for more than 58% of the value generated within manufacturing. So we're looking at a situation where when we're talking about Industry 4.0, we're talking about smaller size companies, okay? So what I want to do is really focus in on a lot of those tactical challenges on the prior slide that I outlined, but in figuring out, telling you guys a little bit more about how do we go about doing this transition. And I'm going to focus on the 99%, but really it's applicable to everyone, including that 1%. And really this transition needs to focus around really three main elements, this being people, process, and technology. And I'm going to explain each of these in detail, but the key takeaway is all three of these must work together, and the benefits to the organization will only accrue as far as the weakest link. So what do I mean by people? People, I'm talking about talent readiness, the structure of your organization and the management. When I translate that to the shop floor, you can even think about transitioning the shop floor from a very much an operator-controlled environment to more of a intervention situation for operators, to ultimately, in some cases, depending upon the application, no operator required. From a process perspective, we're talking about shop floor processes. We're talking about upfront processes in your value stream. So I use the term the carpeted side of the business, all the way through to your supply chain. So these are these processes, and we want to move these from being very much a reactive short-term focus to getting to be more proactive, moving to predictive, which is some of what Mo's going to cover later, and ultimately getting to like more real-time and self-optimizing. And last, we have technology. And the technology is in three areas. We're talking about it from an automation perspective, a connectivity perspective, and an intelligence perspective. And I'm going to cover those on the next slide. But it's moving from this concept of being more analog and manual with your technology to being and utilizing more cross-functional automation, and ultimately getting to more AI-driven type of technology that spans across your value stream. So this technology, let's talk about this in a little bit more detail first. This will be the first item we'll cover. I want you to think about technology like your body. And we talk about it in relation to your muscles, your nervous system, and your brain. So automation and connectivity really focus in on linkages between equipment, machines, computers, and it's really for this collection and integration of data. And this collection of this data is then fed to the brain or the intelligence part of you to sort of process it and analyze it. So again, muscles, this is all the stuff we think about as we relate to Industry 4.0. It all needs to be really flexible. And as we saw in the poll, we need to keep meeting customers' needs, but we really can't afford to overhaul everything. So we've got to be really judicious about where we're going to spend what limited capital we have. The nervous system, this connectivity piece, this is all about the devices and the senses that have gone from being wired and analog to wireless and digital. So we need to establish standardized communication paths and protocols to kind of manage that all. So this is really your IT system, and we're not talking about the IT system that's, the help ticket desk or backing up your servers. It's much broader than that. And last, but certainly not least, it's actually the most important, is the intelligence piece. And this is the technology being used to make you operate faster in a data-driven and an intelligent way to improve your business. If we don't get any smarter and make better decisions, then there is no point to doing any of this. So we've got to make sure that we're doing this intelligently. So, but today, and I think most people on the call know this, people have a pretty skewed perspective of what manufacturing is. They either think it's some dark, gloomy, unsafe environment from, the Henry Ford, Model T days, or they think it's something like this from General Motors or something like this from Tesla, right? This super high tech. Or, maybe they think electronics and wafer manufacturing, and they think about all these big pieces of equipment with, people in, these special suits to kind of, in certain clean room environments. And but I think, or they may even think about things like this, these, special robots driving around IPs all around the floor. And all these things absolutely exist. But I think the Henry Ford model is probably not accurate at all. And these things are probably oftentimes more exceptions than the rule. And I think what we're used to seeing is more something like this. And this is what we see in middle market manufacturing, right? This is an injection molding plant. You can see in the foreground there, we've got one injection molding press. We've got an operator in front of it. She's probably doing some kind of inspection operation or maybe doing some value-added operations. If you look to the background, you can see some people in blue jackets. They're probably doing some inspection. And, there's a lot of boxes around. Maybe today, we might also see something like this, which is just rows and rows and rows of injection molding machines, of which some are running, some aren't. They're old, maybe some older machines or some newer machines, and they're all kind of mixed in. You know, but this, I think we would also consider to be pretty typical. And here you see maybe too much returnable dunnage. We have good lighting. We have a mix of old and new machines. If you were watching this particular cell operate, you'd see that the conveyor belt is in fact actually broken and hasn't worked for 3 weeks. So all of those type of things would be a pretty typical view of what's going on today within manufacturing. And we have a lot of tools at our disposal to continue to make manufacturing better, but we have to recognize we have a wide range of the current state, right, today. And we have all of these new tools that can be used to help transition us faster into Industry 4.0 that you see listed here. And you can see that as you read this list or look at those pictures, you know, a lot of this stuff resides off the shop floor. Yeah, absolutely. Multi-machine cells or CNC machines, those are your muscles that need to operate. But you also see, you know, ERP systems, MES systems, which is, you know, for your scheduling system. And these are very much brain tools. And meanwhile, we have what should be considered givens around IT and security, but really they're anything but. There's whole businesses built around, you know, getting your infrastructure put in place for Industry 4.0 or for cybersecurity. So these things are really big deals that they weren't big deals, you know, 10 years ago. And quite honestly, all of this technology in itself and all this equipment, it's an arms race and it's not cheap. And to what everybody felt like getting the money for that. And it's even tougher if you're not profitable. So this chart that you see here, this is again from a recent study done by Carr. You can see that about half of all companies make less than 5% profit. Okay, so translating that back to our 100-person organization or $25 million company, at a 5% profit, it's $1.25 million. Meanwhile, a decent CNC machine, for those of you in that space, or plastic molding for an injection molding machine, you know that you can get set back. Those things can set you back $200,000 really fast, right? Depending, and it can go up to the millions depending upon the size of the machine. And if we start talking about flexible multi-process work cells, those are in the millions of dollars, and they're out of the reach for the vast majority of all companies. So we have to be very clear about what we want to invest in, because quite frankly, the majority of us who own these businesses were small, were privately held, and most of those have a real aversion to debt, right? They tend to fund everything from cash. So if I'm not making money and I'm not generating cash, it's difficult for me to buy that new equipment. So if we have a limited amount of money, it has to be focused in the right area. How do we know where to focus? It needs to be focused on things that impact the business. It needs to be tied to your business plan. So that's kind of lesson learned number one. So we don't have to spend a lot of money, but when we do spend money, it needs to be tied into our business plan. Now, in the interest of time and kind of continuity of messages, I'm actually going to kind of combine people and process together. Recognize that all three of these things, as I mentioned, are inextricably linked, but I think most people kind of get it that people and process, they sort of go together, right? So I showed you a picture of a bunch of plants with a wide range of different pieces of equipment and what it looks like, right? And really the same thing happens when we talk about our processes, right? So we have some processes going on today that are really manual and paper driven, and others that are very electronic and automated. And often we kind of have multiple processes doing the same things, right? To kind of address some limitation or a workaround in our system. Something doesn't work right. So, you know, Jane always, you know, takes the latest thing and types it into Excel, prints it off and posts it on a workstation or whatever she does. And so we have these sort of different, processes that we're doing. And the reality check is, despite the fact that a lot of people have ERP systems and they implemented them, it really didn't do away with a lot of paper. And in some cases, that's okay, actually. Some of the processes are better off being less automated. But, the reality is also we had some really failed implementations, which means we've got multiple processes we're trying to deal with. So when we think about this transition to Industry 4.0, we kind of have to know what our end game is or what we're trying to actually get done. And we have to think about it in relation to the technology, and we have to think about it in relation to this process, right? So when you're thinking about this, quote unquote, what are we trying to implement or what are we trying to automate, the best practice is tying these transition plans, as I mentioned, to your business plan. Because as you think about your business plan, you're saying, hey, look, I got to achieve this revenue, I got to achieve this level of profitability, but I got these specific goals objectives that I'm trying to put forth. And when you talk about those goals and those objectives, they're usually at a system or process level, right? So we have various systems that are built, that run our business, that are built off of various processes, right? A production scheduling process, an estimating and quoting process, design and release, program management, you name it. We have all these processes that are done. And these processes span a bunch of different functional areas or departments, right? And so all these different functions are doing various tasks to achieve these different processes to get things done that we need to do. So the idea here is we want to know what we're transitioning, having some sense of where we're going and what we want to automate. We don't want to make this an extra credit assignment. So we want to tie it in to our existing systems and processes. We want to tie it into our existing business plan. And ultimately, we're going to ultimately try to pilot something. And Mo's going to talk about this in his deck. He's going to talk about thinking big, but starting small. So we can start with automating at a task or a subtask level, whether it's a load or an unload, a sort and inspect, an alert, or a compliance type of activity. But we want to understand how it fits into the larger process, right? So we're not going to implement in isolation of a business need, okay? And ultimately, when we think about this, it's really, this transition is all about change management. And since the dawn of time, technology has always outpaced people's comfort level. I'm sure there was a caveman out there that thought that fire wasn't going to be the next big thing, but it was. Technology really changes exponentially. People and organizations don't. They change logarithmically. And the risk for everyone in this transition is in this middle area. If you don't adapt your processes properly to the new technology, if you don't get people on board, you're not going to get a benefit. So guess what? It's kind of leadership's responsibility to kind of shepherd this along, because people and processes need to change. And, we really don't have a choice. This has to happen. And you say, well, James, why does this have to happen? You're seeing it in your own business. We've got workforce demographics that are changing. I talked about this earlier, we've got fewer skilled trade workers and just less people available to do the work. We've got a real capacity constraint. Now, at the moment, you could probably go find lots of restaurant and bar workers temporarily if you need your plant to run, but we know that once this situation kind of recovers and these bars and restaurants open up, those people are going to go back to work. Further, the needs and expectations have changed for what is required in our business. This has been driven by our customers, our suppliers, heck, our employees, and our community at large. There's new positions now that we needed that didn't even exist a few years ago. I mean, who heard of a data scientist 10 years ago? And I already talked about all the IT and infrastructure that's got to get accomplished. But one of the biggest things why this transition has to occur is, look, the gut instinct isn't always right anymore. And it's probably going to be a lot less accurate going forward because your business, you recognize this, your business is way more complex. You need help sorting through all the information and to help make the best decisions for you. You know, I did a study at my old company last year on the use of business intelligence tools, and it was interesting what we discovered. We did this big analysis, and we found out, you know, not surprising, those that use data win. And what do I mean by a business intelligence tool? This is like a dashboarding of your existing data and your information. And you can do this through Power BI, Click, Sisense, Tableau. There's a lot of different BI tools out there. But what was found out was companies that use and have implemented BI tools were 11% more efficient, as measured by what we call throughput, which is value-added revenue divided by full-time equivalent employees. So you say, oh, you know, 11% seems like a lot. Like, what does that mean exactly? Well, let me translate that for you. That 100-person plant again, they can launch approximately $2.4 million of new or incremental business with no additional labor. So this solved a lot of problems. And guess what? What does that do for profitability? That's going to double that $25 million company's profitability if they were at the 5% mark, if they perform this. So just simply using a BI tool drives a cultural difference within the organization. And I really feel like this slide's a good lead-in for Mo's part of the webinar. He's going to kind of cover now in detail some of the case studies that are going to prove the value on this stuff to say, now, what can you go do provided it's tied into a business need within your organization, because then you'll be motivated to do that. So with that, I'm going to turn it over to Mo.
James, thank you for the presentation. And I fully agree with two main points that you've stated very clearly. Number one, it is all about a business plan, and the business plan drives the technology selection. And number two, those that use data win. And that's actually the focus of the second half of this presentation. I would like to talk about the role of technology in Industry 4.0 and how you can use data to win. And I'm going to explain three cases. I'm going to talk about what is industrial IoT and predictive analytics. I'm going to talk about predictive analytics technology and case studies that can drive you winning with data. And we will conclude with some lessons learned. So let's start. James defined Industry 4.0, and he defined it in an abbreviated way, which made a lot of sense. But if we dive a little bit deeper, you know, Industry 4.0, or the fourth industrial revolution, is, as James well stated, it is a transition. It is a transition away from, you know, old approaches to collect data manually into new approaches to digitize and digitalize and connect your operations. Connect your operations using the cloud, using analytics, and then driving the use of data to improve productivity and to deliver a very strong business case. So in fact, Industry 4.0 was originally a German government-led initiative, and the Fraunhofer Institute and a lot of the German industrial members were a key part of this initiative, or forming this initiative. And when it came to North America, the United States, for example, the National Association of Manufacturing, NAM, they refer to it as Manufacturing 4.0 or Smart Factory or Digital Factory, right? So there's a lot of namings out there, but one of the cornerstones of the Industry 4.0 initiative is a so-called cyber physical system, or a CPS. And what this means is, you know, cyber is the internet world. It is the use of IT tools, and physical are the physical assets and operations and the plants that are running today. So cyber physical systems is the creation of digital twins and mirroring the physical world and the plant operations into the virtual world in order to use analytics, to use cloud to drive improvements, right? So if we go on a higher level, on a 35,000-foot altitude, when we look at IoT as a whole, IoT is not new by any means, okay? You know, the Internet of Things has been around under possibly many different names and is widely used mostly in safety critical industries, aviation, power plants, renewables, nuclear operations, right? So the collection of data and the use of analytics in those safety critical environments has been around for decades. But using some of those lessons learned, and as the computational powers are evolving, and as the internet speeds are evolving, the Internet of Things, or the tools and technologies used there, has started to go into the manufacturing industry, and therefore was born the IoT, or the Industrial Internet of Things. So if you look in a manufacturing facility, the ISA 95 standard layers, for example, you have the machine layer, you have your CNCs, your PLCs, your sensor layer, you have your data acquisition or SCADA layers, you have manufacturing execution systems that are marrying the machine layer with your business layer, that's your enterprise resource planning. And when we did the poll earlier, a lot of folks mentioned that some of your challenges are, the lack of integration or even the lack of existence of some of those layers in your manufacturing operation, right? So the Industrial Internet of Things and the Industry 4.0 movement or initiative is looking to marry the IT and the OT world and to close the gap between some of these fragmented layers that you see here, okay? So the flow of machine data directly into MES systems, directly into ERP systems, and then they use all that aggregated data to drive analytics into the manufacturing environment. So this is how we see IoT, IIoT, and Industry 4.0 or Manufacturing 4.0 as an initiative driving business plans and business wins for manufacturers today. So when we sum all this up and we talk about what is a digital transformation strategy for a manufacturer today, we think about 4 pillars, okay? 4 pillars of that strategy. We in most cases actually start here from the right and we count backwards. We first think about what is the business plan, okay? A big challenge, as you've all polled, is I don't have money to invest in this because in most cases we are not looking at the ROI side of the equation, right? So what is the ROI? Are we looking for uptime gains? Are we looking for scrap reductions? Are we looking for optimization of spare parts? Are we looking for optimizing the preventive maintenance schedules in the manufacturing environment, right? So once we hone in on the ROI and the business case behind the initiative, we are able then to go into, hey, am I connected? Do I have data that I can use, right? I have new machines. I have old machines on my factory floor. How can I get relevant data parameters in real time from my assets that are able to then drive my business case and my technology deployment, right? And once I'm connected and I have that level of maturity, I'm able now to use data to drive analytics, to drive what we call performance analytics and metrics like OEE, for example, overall equipment effectiveness tracking, and to drive predictive analytics that allow me to get a proactive view of what may be happening in the future to the assets that I have on the factory floor. And then we talk about technology, right? We talk about scaling those technologies across multiple sites or multiple machines. We talk about IT infrastructures required to do that. We talk about cloud-based solutions, on-premise-based solutions, right? So digital transformation strategies allow you to understand what is the ROI for my investment, what is my business case, and then allows you to capture the data you need to analyze and to drive your continuous improvement cycles across your operation. So then we say, hey, digital maturity varies from one manufacturer to one manufacturer. Even within one manufacturer, if I'm running multiple sites, I have varying levels of digital maturity from site A to site B to site C. And it's very important for us when we set and execute a digital transformation strategy to understand what is the maturity level of the company and what is the maturity level within each plant within the organization in case of a multi-site organization. So we define a 5-level maturity model, okay? And there is a variety of maturity models out there, but I'm gonna, show and demonstrate the simplest one for the discussion today. And when we do our training sessions, we go much deeper. But if you're a level 1 maturity model, this is a standalone manufacturing environment. It is disconnected. There are missing business systems. Maybe there's no MES. There's a lot of manual data collection on the factory floor. And I really like the term accidental excellence, because sometimes, even though the operation is standalone and so manual, folks are still able to use manual data to drive improvements on the factory floor. Okay. The second level is I'm anticipating. So I have started to embark on a smart factory journey. I've connected some of my assets. I'm measuring real-time KPIs like OEE. Maybe I'm using a machine monitoring solution, right? But my other factories and my supply chain are not yet connected to what I'm doing. So I have a single site excellence. I have one smart factory or one connected factory. And I'm anticipating the future. And then you have a level of integration. You have an integrated multi-site smart factory operation where multiple plans can be benchmarked and where metrics are rolled up to the organization, so you can compare what's my OEE in plant 1, plant 2, plant 3, and at the same time my MES is feeding data to my ERP business system, and I have a corporate platform and a connected operation across multiple sites within my manufacturing network. And then going beyond, there's a collaborative setting where analytics can then be used, in specifically predictive analytics that we will discuss, to drive further proactive decision making, to order new spare parts before machines fail, and to optimize and sustain high levels of OEE and being ahead of the curve. Okay, this is what we call a level of collaboration, collaborating maturity level. And finally, going beyond predictive analytics, how can real-time decision-making happen by using prescriptive analytics and diagnostics and even self-learning approaches where lights-out manufacturing can be in place across the supply chain and across a multi-site organization, right? So I'd like to pause here and just have the audience digest this and think in the back of your mind. And if I ask a question, how would you self-assess your company today? Okay, if we run a poll now via Courtney, just select 1, 2, 3, 4, 5. Where are you today, and how do you self-assess your digital maturity today?
Thanks, Mo. We have that poll running for you now. Looks like about 30% of you have voted so far, so get in there and answer that poll for us. We have currently, the majority of our participants today are saying that they're anticipating. We have 21% saying reacting and 13% saying integrating. So I'll give it just a few more seconds. If you haven't voted yet, jump in and let us know. How do you currently assess your Industry 4.0 digital maturity? All right, so we have 19% say reacting, 47 anticipating, and 24 integrating, 12% collaborating. Great, thanks guys. I'm gonna go ahead and close that poll.
So the rest of the presentation actually is gonna address more of those anticipating and integrating maturity level folks, the 2s and 3s, and how you can migrate or transition, using James's term, transition into a collaborating level 4 to level 5 maturity scale, okay? And we're gonna focus that on the business case behind using analytics, specifically predictive analytics on the factory floor today, okay? So, the business case. Money is tight, margins are slim. As James mentioned, 50% of companies operate on actually less than 5% margin. I personally have not seen that number before, and for me, it's a strong statement, okay? And therefore, ROI is king, right? What is the business case that I need in order to run such solutions on my factory floor? I need affordable solutions. I need ROI-based solutions. And therefore, we look at two things. We track metrics like overall equipment effectiveness and specifically uptime gains by using predictive analytics on the factory floor. We track the opportunity to detect faults early on the factory floor and reduce unplanned downtime significantly by doing that, by catching faults before they actually happen. We track the impact of feeding those predictive insights to your maintenance system, right? To your Maximos and SAP PMs and Infors. And by leveraging this, by leveraging predictive insights and knowing machine failure before it actually happens, how can you optimize and even minimize spare part inventory on the factory floor? We talk about optimizing preventive maintenance schedules, because now that I have a buffer of time in order to optimize PM cycles, I can reduce labor times. I could even eliminate weekend maintenance in some cases, and rather than fight fires, move from a reactive to a proactive maintenance environment. And the numbers you see on the right are actually true numbers pulled from some folks out there today that are using these technologies, right? We're talking 5 to 10% gains in OEE. We're talking, 5% uptime gains. We're talking reductions of spare part inventory by minimum 10 to 20%. We're talking PM time reductions and improvements in mean time to repairs and mean time between failures, right? So it is important when thinking about the business plan to understand what metrics drive success. And by understanding those metrics, we track those metrics, and then technology deployments are attributed to making an impact on those metrics. And obviously those metrics translate to dollars, okay? So here's an example, actually, a very short example of a larger organization, right? But they were just thinking about uptime. I mean, just imagine this is an automotive OEM. A cost of 1 minute of downtime on their factory floor is almost $10,000, right? And numbers have been increasing over time. But, out of the 500 robots in the factory, only 30 robots typically fail per year. I mean, robots are pretty rugged, equipment, but the issue is when they fail, they typically take about 30 minutes of unplanned downtime, and that skyrockets the unplanned downtime cost. And by using predictive analytics and even under promising only a 50% prediction accuracy, okay, and that means only predicting 15 of the 30 robot failures every year, again, significant annual savings can happen within their operation. Actually, the ROI was less than 12 months, and it was exceeding 100%. So I'm not saying that your downtime in your factory is $10,000 per minute, but I'm saying is the value of uptime improvement and catching faults early in a manufacturing operation can add significant value to the clients and significant value to your maintenance function. And this is not including spare parts. This is not including PM improvements, right? On the other hand, by using predictive analytics tools, it is also very important to think of the people factor, the human element, right? Those solutions out there, those data science-based solutions or AI-based solutions, they have to be built in an intuitive way to allow the maintenance organization to be able to use those tools and to trust those tools, right? And you do not need to be a data scientist or a PhD to use those tools, because the skill set of the maintenance organization is not that type of skill set, right? So it is important to show them health. What is the true health of your asset? When is this machine going to fail before it actually fails, with an accuracy and a diagnosis of the root cause of the failure? Those are three key metrics that we introduce to the organization as part of a predictive analytics effort, okay? And it's very important to understand those metrics and to use those metrics to drive improvements in the maintenance cycle at the customer. So let's talk about those three metrics, okay? When we look at predictive analytics, we're talking about the use of industrial AI, industrial artificial intelligence tools and techniques to convert data, what we call the data lake, of assets and sensors and process parameters and quality information, to convert that data into two main use cases that drive analytics on the factory floor, okay? One of those use cases is predictive maintenance, the other use case being predictive quality. Predictive maintenance is focusing on the machine itself, and predictive quality is focusing on the part that is being produced by the machine, okay? So we're using streams of big data that are flowing into the solutions in order to digest that information and convert that information into simpler, actionable information that can be used by the maintenance and quality organizations within the clients, okay, to drive improvements in maintenance and reductions in scrap. So obviously, within a manufacturing environment, not all equipment is the same, right? What I'm showing here is some examples of most commonly found processes in a manufacturing environment. So we're talking robotics, we're talking machining, CNCs, injection molding, casting, and so on. We're talking stamping and press operations, and we're talking a lot of ancillary equipment that surround the factory and the machines, including pumps and motors and so on, right? So a predictive solution or predictive analytics differ from what we call template to template, right? So when we're looking into robotics, we're looking, for example, within the axis of the robots. We are collecting data from each degree of freedom axis, and we're using data like torque and current and temperature to drive a baseline and to understand what is the true health of every axis of the robotic. When we're looking at a CNC machine, we're looking at critical components like the spindle bearing, where we are receiving vibration data, and the feed axis ball screw, where we are comparing the actual position and the commanded position of the ball screw. We're looking at the coolant, where we're collecting data like pH and current and oxidation, right? So it is not a one-size-fits-all, but there is, 25 to 30 different sizes or templates, what we call solution templates, that, we would cover in more detail during a training session. But within each one of those solution templates is a systematic predictive analytics process, okay? It's actually a 6-step process. Starting with collecting data, we define what's called a data model, specific parameters that we would obtain from the CNC or PLC or from adding sensors to the machine. We talk about using machine learning to process the signals, extract statistics and features and metrics from the raw data. We talk about creating a baseline. So what is a signature of where my data and where my machine's health is today, and trending that signature or fingerprint over time. And a degradation occurs when we drift away from the original baseline or signature, right? So that is the definition of health. Once we have a health model, we're able to then offer predictions over time. And typically with less historical data, prediction accuracies start out as being lower, and prediction accuracies improve over time based on historical data collected. And finally, we talk about diagnostics. So what is the root cause of the failure? Is it a temperature spike? Is it a pressure spike? Or is it a inner race failure within my bearing? Is it an outer race failure within my bearing? So true diagnostics require what's called supervised learning, where you have signatures and history of different types of faults and issues that happen on this machine or component over time. So this is not a 1 to 6 process. It is a 1 to 6 repetitive process. This is a recipe flowchart, or an analytics recipe, we call it, that is continuously self-learning and evolving as you collect more data and as you run those solutions to deliver value to the customers in their analytics journey. Here's a quick example before I conclude for smart machines, right? I mean, this is not a robotic. This is a more complex piece of equipment. The equipment's got tools, it's got bearings, it's got coolants, it's got feed axis, right? So multiple templates are required here. Multiple data models are required. And then at the end of the day, there's a defined data model. There is vibration data that needs to be collected from the spindle, right? There is current and speed data that need to be collected from the actual controller using protocols like OPC or MT Connect. And then there is the maintenance user who, again, he or she requires an intuitive view of what is the health and what is the diagnostics and what is the prediction of each of the critical assets of this machine, right? So the message here is, for those folks who have achieved kind of a level 2, level 3 maturity, those of you who are anticipating and integrating, there is significant opportunities to further get connected and to start realizing and using analytics to drive your maturity levels beyond into a more collaborative and an orchestrating manufacturing environment. And that is what predictive analytics and such technologies allow you to achieve. So I'm going to summarize and then hand it to James for his summary, right? We truly believe that digital transformation is a journey, okay? We think big, we start small, and when we start small, we prove value with clear success criteria, and we scale fast. And at IoTco, we have an approach that we go through. We call it a 3D approach. We discover, we design, we deliver, okay? And it all starts with the discovery. It starts with education. It starts with awareness. It starts with understanding your digital maturity scale and where are you today. It goes into workshops where gap analysis is done to clearly baseline and understand where are you around people, process, technology. Things are piloted and things are proven. Start small on a small scale with clear success metrics and with an ROI and a business plan to back it up, okay? And then scalability is done. And scalability requires thinking of the business and the technology at every step, and it requires the understanding of what we call a center of excellence that is a pivotal organization within the client that understands and is trained on that technology and supports in the scale of that technology, right? And we go through this, through much more detail during the training sessions, but we wanted to give the audience today kind of a glimpse into how we tackle such a transition journey into Industry 4.0. James, if you'd like, please wrap it up for us.
Sure, and I think that's a good summary for our first bullet on the lessons learned, which is start today, think big, start small, right? So to Mo's point, there is things that we can do, and when you see that approach laid out, it does also answer one of the polling questions from earlier. It's like, I'm not sure I got the right people in my organization. Well, that's what you got partners for. That's what you got people who know this stuff that can kind of come in temporarily and maybe fill in some of those gaps or perform the training. And I think you'll be surprised by what some people in the organization will pick up and run with. So but the second lesson learned is, right, we're going to make it operational. We're going to do a proof of value. So we're going to show a benefit to the organization. We're not going to act like this is the flavor of the month, but we're going to talk about it in terms of a transition. And ultimately, if we align it to our business plan, honestly, we should be less apt to fail at it because it should be getting focus and attention, but using a good methodology around think big, start small, we should get success. It's built around everything we're focused on today. So the lesson learned is we're going to take that whole system that Mo laid out around the smart connected factory and go, what are we focused on? Downtime, zero defects. What can we do here? Because that's what we do every day. So now we're going to take the tools and take the smart connected factory tools and apply them to the age-old problems of safety, quality, delivery, production, and all those sort of things, right? And we want to make sure that we stay smart with what we're doing. So we're going to stretch and be able to make sure our maintenance people are working with an optimal set of information because we've got limited resources, for example, with the maintenance folks. And we don't want to buy a bunch of equipment that we don't necessarily need. So we're going to leverage all of those connected products and use all the analytical tools to bring forth. And again, we have to know when we do that gap analysis, where's our blind spot? Is it people? Is it process? Is it technology? And when we finally fix one, what's the next bottleneck in that process? We got to know what we're up against because ultimately benefits only accrue as far as our weakest link. So we can implement the best it goes without saying, we can implement the best ERP system in the world, but if we don't train our people on how to use it, we just wasted our money. So with that, this is kind of the key lessons learned. I really appreciate, and I know Mo does as well, everybody's time. Courtney, I was going to turn it back over to you to see if we've got some questions or comments.
Yeah, great. Thank you both for wonderful presentation. I know we are coming up. It is 3 o'clock now. But we do have some time. We can stay on for you if anybody has any questions. If you want to go ahead and put them in the questions box, we appreciate it. All right, looks like I have one here for you guys, Mo or James, whoever can answer for us. Have you dealt with environments that have no support from areas involved or have no time to provide data in order to proceed with the implementation or transformation?
I can briefly start, and James can chime in. I mean, we've definitely worked with environments where there was limited support, and I think that's something we like to catch early on when we do the discoveries and the maturity assessments for the plants. I mean, that's a very valid question. It's very important that we all understand this is a multidisciplinary effort. It's a role-based effort. You know, there needs to be an executive sponsor. There needs to be involvement from, you know, maintenance, production, purchasing, and other, you know, sectors within the business, right? And what if we set things up correctly during the initial discovery and maturity assessment, then I think we will not face that challenge that in the future we're missing support. So I think it's all about the setup, and it's all about proper assessment and building the right team to back up the digital transformation journey and transition that's going to happen.
Great, thanks. So we do have. Sorry, James. Go ahead.
Courtney, was part of the question. I'm sorry. Was part of the question around a lack of data availability to know where to start? Because fortunately my phone cut out.
Yeah, no problem. Yeah, part of the question, the second half of the question was no time to provide the data in order to proceed with the implementation. So yeah, either the time to provide it and get it together to get it started perhaps, or just if the data is bad and or not available to those stakeholders, I guess.
Okay. Well, I think Mo answered it overall. I guess we go back to, we want to make sure it's focused on business objectives. So if we're focused in on something that's very important and critical to the business, and we have no data and information on it, that's a pretty sizable gap in how we're executing. Nonetheless, I'm actually working with a company right now where 9 months ago, they didn't have the data. And we had to start the process. We couldn't wait till we collected all the data to figure out what we needed to do. So we took professional judgment of the maintenance guys, of the production manager, and we started there. And we also started to collect data. 9 months later, that data is now being put into an AI system to be analyzed so that we can improve upon kind of what we started to do. And we've had to work backwards to fix a lot of the processes so that we can collect the data on a regular basis and know that it's clean and good. So it is not ideal to operate that way, but it wouldn't be mine or Mo's first rodeo if you went in and felt like your data wasn't, you know, there and necessary. But it's back to leadership's commitment to making sure that this is a critical thing to work on.
Great, thanks, James. We did have another question come in through the chat. How long does a typical Industry 4.0 transformation take, and what are the typical costs associated or cost range associated with the transformation?
James, you want to start?
Yeah, I'll start. I guess I'll use my way back background of when I did a lot of lean manufacturing implementations. People would say, how much, you know, how long does lean take, or how long will it take me to implement lean? And it, you know, there is no answer to that question. You're gonna, it's a rejiggering of your thought of how you utilize your CapEx and your CapEx investment and what you spend it on. In addition to equipment, you're spending it on information and integrating that and just making the right spend on it. So it can be really inexpensive depending upon what you have going on. It may end up being that pilot, maybe a couple of sensors and some of the software that Mo's referenced. It can be relatively inexpensive. If you've got a lot of dumb equipment that's critical to your operation, maybe there's a few more controllers we need to buy. It's going to range. There is a $20 million plant I'm working with that over 5 years, they need to spend over $300,000 upgrading their systems, and they're a $20 million company. So it can get pricey, but it doesn't have to.
I agree. And I agree with James. You know, this is an evolving strategy, and it's very good to understand the total cost of ownership and to do it tactically. So what are the short-term costs and what are the long-term costs in the next 3 to 5 years? And just keep in mind the ROI. Am I getting year-on-year ROI gains from using those solutions? Or do I need to pivot? Do I need to move into a different plant or move into a different process? So I think cost aside, keeping the ROI and the total cost of ownership and thinking short-term and long-term is key when we create a digital transformation strategy.
Excellent. I'm gonna. I know we're kind of past our time, so I appreciate everybody sticking around. If we have any more questions, you can throw them in the chat and maybe take one or two more. Let me see. What do you advise for scaling digital transformation efforts across multiple plant locations?
I can quickly say from the technology side, it's important to think of templates. When we talk about a rollout plan of a digital solution across multiple sites, we need to look at how much variation there is. I have a customer, for example, they're very standardized. They have 100 casting machines, and the casting machines are pretty much the same across 7 plants, right? So that is a template for casting that can be scaled fairly easily across multiple sites. But I have another client, they have 25 plants, they have a steel side of their business, they have an aluminum side of their business, they have CNCs and molding and low pressure casting machines. So we're thinking here, we're talking multiple templates and scaling multiple technological solutions across multi-sites, which can be more difficult. But it's just very important to think, how much variation do I have? And also, what is the maturity and the connectivity and the skill set levels, people, process, technology per site, allowing the scalability plan for the customer?
Wonderful. Thanks, Mo. Don't have any more questions coming in, so I'm going to go ahead and get us wrapped up. Thank you both, Mo and James, for joining us today. And thank you to all of our attendees for jumping on here with us today. Here is Mo's and James' contact information if you'd like to reach out to them for any more information. And then also, I'd like to invite you all to our event, the Leadership Seminar, The Journey to Industry 4.0. Both Mo and James will be speaking at the event. Originally slated for early May, has been postponed, but we will get you more information when that event will happen. It's a half-day event that will be taking place at Foreseeable in Auburn Hills, Michigan. So we hope you'll join us there. Also, if you'd like to hear some more from Mo and James and others, please check out the Digital Enterprise Society podcast. It's available on all of your favorite podcast streaming platforms. And a recording of today's presentation, as well as our past webinars and upcoming webinars, are available at digitalenterprisesociety.org/webinars. We'll hope you join us in April for The Promise of IoT and Digital Twin from Craig Brown and Matt Hang from Vertex. And then finally, find us on, keep up to date on what we're doing, what's going on in the latest news around digital enterprise and digital transformation by finding us and connecting with us on Facebook, LinkedIn, and Twitter. Again, my name is Courtney McWhirter, Marketing Communications Manager for Digital Enterprise Society. If you have any questions about getting involved or joining, please feel free to reach out to me. I'd love to help you out. Finally, once again, Digital Enterprise Society is a new nonprofit member association organized to enable transformation of product development, design, delivery, and maintenance throughout the digital enterprise, regardless of the software tools used. Visit digitalenterprisesociety.org to learn more. I thank you all again for joining us today and for putting up with any audio or technical issues you might have had throughout, as we know all of our systems are a little bit more taxed with all of us working from home right now. So thank you all for joining us, and we'll see you next time. Thank you. Have a great day.